Everyone, welcome to the Ideas Academy. So today we are going to perform dialysis on the enzyme. Like in the enzymology series, we are going to perform dialysis. Okay, this is the next step after salt precipitation, which we performed earlier. So for performing dialysis, basically, we required obviously dialysis membrane, which is a semi-permeable membrane, and this is a dialysis membrane, which I measured and cut at 8 centimeter. Do you know dialysis membrane is made up of what? Okay, let me tell you, dialysis membrane is made up of cellulose acetate. Okay, so for performing this experiment, we required few of the chemicals. In that, first of all, we required 2% sodium bicarbonate. So, which means we need to dissolve 2 gram of sodium bicarbonate, which is NaSCO3, in 100 ml of distilled water. So here we are having 100 ml of distilled water. First of all, I'm going to pour half of this in beaker. So, and now this is our already weighed 2 gram of sodium bicarbonate. I'm going to dissolve it in the this water. Okay, now shake it properly. So after dissolution, add remaining water to make up a volume of 100 ml. So our 2% of sodium bicarbonate solution is prepared. Other than this, we required 50 millimole of potassium phosphate buffer. See, this is a buffer which we used in salt precipitation as well, like in which we prepare two kind of solution, monobasic and dibasic, and then we mix them together, maintain their pH 7, and to prepare this 50 millimole of potassium phosphate buffer. How we prepare this, how monobasic is formed, how dibasic is formed, it's we already explained in a salt precipitation. So if you want to know how we prepare, you can go through with the salt precipitation. So here our 50 millimole of potassium phosphate buffer is prepared, whose pH is already maintained, that is 7. So now the very first step which we are going to do, we need to activate our dialysis membrane by boiling in distilled water for 10 minutes. So now I'm going to do this. So here we already this start boiling the water. Now I'm going to pour this dialysis membrane inside it and noted the time for the 10 minutes. So after adding 2% of sodium, like first of all remove the remaining solvent, that is distilled water. In 10 minutes we kept in for boiling. Now I remove the solvent with 2% of sodium bicarbonate, and again we need to kept it for the 10 minutes for the activation. And after activation of it, we transfer we again transfer its solvent to the distilled water, like from this 2% sodium bicarbonate to distilled water for activation of the dialysis membrane. So now after 10 minutes we change the solvent from sodium bicarbonate to again distilled water. So I am taking this solvent in a beaker and now adding distilled water as a solvent. Again we need to boil it for further 10 minutes. So let it be boiled for the further 10 minutes. After that we are going to pour enzyme into the dialysis membrane. Like after this, our dialysis membrane will be activated. Now after boiling it in distilled water for the 10 minutes, I am taking it out. So here are dialysis membrane. So now after taking it out, and I tie my dialysis membrane one-sided from the thread. Okay, you can just tie it with the thread. One end will be tied with the thread. Now from the other end, I'm going to add ammonium sulfate precipitated enzyme solution. So here it is our ammonium sulfated sulfuric precipitated enzyme solution. Now I'm going to pour it. in the dialysis membrane. So one ml. Here our dialysis bag is ready, which is containing our ammonium sulfate precipitated enzyme solution. Now the bag was kept in a beaker containing 50 millimole of potassium phosphate buffer, and this system was incubated at 4 degrees Celsius overnight. So now I'm going to put it inside the. Okay, so now, so this is our 50 millimole of potassium phosphate buffer. Now we need to keep kept it overnight at 4 degree Celsius. For that I'm going to put it inside the refrigerator. So we will see its result tomorrow. So after overnight incubation, now continuous stirring was done so that the like and buffer was changed at a regular interval for 30 minutes for 3 hours. So we are going to change its buffer after interval of every 30 minutes on the continuous stir, so that our dialysis is completely performed. After that we are going to perform ion exchange with the help of this dialyzed protein. So after 3 hours, our this protein, like this enzyme, is completely dialyzed, or a dialysis is completed basically. Now this dialyzed protein will be centrifuged at 6000 rpm for 10 minutes, so that if any impurity is present, it should be removed. But it's not sure that impurity will be present. Might be there is no impurity, but for our security purpose, we are just performing the centrifugation at 6000 rpm for 10 minutes. So now after cutting the dialysis membrane, I am just going to take out this protein enzyme and now pouring it into the. So take out it very carefully. Just reducing its size so that the micropipette can easily go. So now I'm going to set the Eppendorf. Time is 10 minutes. 6000. So here it is. And now I'm going to put these Eppendorf inside the centrifuge. You need to balance it carefully. Okay, like this. And now let's wait for the centrifugation. After 10 minutes, I will continue it. So now after 10 minutes, I'm taking out these Eppendorf from the centrifuge, and let's see one. Okay, you can see in our protein there is no impurities. But so as you can see in our enzyme, there is no impurities, but for our satisfaction of our better result, we perform centrifugation. It's not any like a compulsion or a bigger task, but yeah, you can say it. So now by using this dialyzed protein, we are going to perform ion exchange chromatography, which is another step for this enzyme assay. Hopefully you understand this entire experiment, like how we perform dialysis and how we dialyze our enzyme and etc. If you are having any doubt, just let us know in the comment section. Thank you so very much. Like, share, subscribe ITLS Academy.